Hey guys, welcome back to my channel. Today we are going to do another important binary tree question. So this question has also been asked in a lot of big companies. So this is very important as like from the interviews point of view. And this is also something which people sometimes use in like applying this concept in development side also. I have used it once in one of my company. So if you are going to appear for an interview, you should definitely do this binary question. So uh, so we have already done a question called lowest common ancestor of a binary tree. So today we are going to do the another version of this, uh, which is lowest common ancestor of a binary search tree. Okay, so without further ado, let's jump onto the question. Okay, so we know what a LCA is. We got to know it in the previous questions that we did. So LCA is the lowest uh, between two nodes P and Q as the lowest node in the tree that has both P and Q as a descendant. So the lowest node which has, suppose for 0 and 5, the lowest common ancestor will be 2 because this is the lowest node. Or if you go from down, this is the first common node among 0 and 5. Okay, so okay, so this is, we have done it for a binary tree. Both that solution will also work for binary search tree, but here actually we can modify the solution to work in a better way, because the tree is a binary tree, a binary search tree, and we can utilize the properties. So what is the binary search tree? Binary search tree is a tree where the root node, the value of the root node is greater than all the values of all the nodes on its left side and less than all the values of the nodes on its right side. Okay, and the same should be true for every node. So you want to find out the lowest common ancestor between 0 and 5. So let's think about it. See, we are given the nodes 0 and 5. This is a, let me just draw the tree. So, 9, 3, 5. Okay. So if you see P is 0, Q is 5, and the current node's value is 6. So it means that both of these nodes are lying on the left side of the current node. If that is so, then this node can never be the LCA of these two nodes, right? Because for a node to be a LCA, the both of the nodes should lie, like one should be on the left side, other one should be on the right side of that node. Then this node will be LCA, right? So this node will not be LCA. So where should we search next? So what will happen in binary search tree is that we can reduce the search space. If it was a binary tree, we don't know where else to go. So we'll go to every other possibility. But here we know that the values of P and Q are less than 6. So for sure, we are not going to find them on the right side. So we should go on the left side, right? So now we'll continue our search on the right side because P and Q both are less than roots value. If it was greater than roots value, we'll continue the search on right side. If they were one were less and other one was greater, then current greater than or equal, then current node will be the LCA. Got it? So we'll go to the left side. Now see the value 2. Now P is less than 2. q is greater than 2, which means that p lies on the left side, q lies on the right side, meaning this node here is the LCA. If you take the example of p equal to 2, q equal to 8, then starting from the root node itself, one of the node lies on the right side, meaning if it's less than root node, other one is greater than root node. So this node itself is the lowest common ancestor. So what is happening here? We are reducing the search space every time. So the time complexity of this solution will go up to log of n, because at every node we are making a decision. We are discarding half of the tree. So either ka khali, now we are only going to this side. Every time we are doing the same thing. So we are only going to touch log n number of nodes. So the time complexity will be log n. So is the same. So is like, which is the case every time we search a node in binary search tree. So it's definitely a better solution. So we can code it out. But if you remember the solution that we did in binary tree, it was uh, it was it was like one of the nodes should be on the left. Same property we were using, that one of the nodes should be on the left side, one of them should be on the right side. But we were going and searching in the whole left subtree. We were going and searching in the whole right subtree for the nodes, right? But here we know where these two nodes can lie. So that is why this will be easier than that one actually. So let's go. Okay, so let's code it out. So the base case will be if the root is null. Okay, if the root is null, the root itself is null, then we have reached the leaf node. So we will return null from there. Now we need to check for the current node. We need to check if the values are on the one is on the left side and on the another one is on the right side. How do we know that? We compare the p and q key value, and one is less, another one is greater. So we return, so अपना LCA will be the current node. So how will it be like? Two conditions. Key p dot value is greater than equal to root dot value. There will be or, and q dot value is less than equal to root dot value. Okay. And otherwise उल्टा कि ये वाली वैल्यू छोटी हो and ये वाली वैल्यू बड़ी हो. If this is the case, then this node is our the root, current root is our LCA. तो we return root. Otherwise, if now अगर देख लो कि दोनों values if p dot value is greater than root dot value and q dot value is greater than root dot value, meaning that LCA will be on the right side. If both of them are greater, the LCA will be on the right side. So we return root dot left p, right? Else we return, else the LCA will be on the left side. Sorry, if both are greater, the LCA will be on the right side. Else the LCA will be on the right side. Okay, let's run it. Okay, this seems to be working. Submit करके देखते हैं. Right, this works and it works perfectly fine. So the time complexity will be big O of log n. Same as the binary search tree में कोई भी हम लोग search operation करते हैं तो it will be the same. Okay. Okay, guys. So see you in the next video. So we'll do another important question actually. So all these questions are very important as a point of view from interviews. So if you are finding it helpful to you, please support me by liking or adding a comment telling me what can I improve, or if you liked something about the video, tell me that as well. And yeah, let's study together and let's grow together. Okay. Bye guys. Thank you.